Hey guys, I hope everybody is staying warm and staying safe. Today we're just going to go through a short lesson that is about just basically an introduction to functions. So we're going to just go right into it. So what is a function? So if you can think back to Algebra 2, what do you remember about functions? Well, the first thing a lot of you might say is that it involves f of x or h of x. So the symbol that we're going to use to represent our function is f of x, or you may see a g of x or an h of x, etc. So that's how we're going to denote a function. But what is an actual function? So how would you define a function? Well, a function is simply a rule that says for every x, there is exactly one y. So for every x value, there's exactly one y value. So what that's saying is it's saying an input value, which is basically just all your x values, cannot go to two output values, which are going to be your y values. Well, how are we going to determine if something is a function or not? Well, one way to determine whether it's a function is simply going to be to look at its graph. And we're going to use the vertical line test. Alright, so the vertical line test is very easy. You don't actually have to draw a vertical line, but you can if you would like. So basically what you're going to do is I'm going to drop down a vertical line anywhere on this graph. And notice it crosses the graph twice. So what that's saying, it's saying for that x value, so where I drew that vertical line, so when x equals 2, it actually has two different y values. So that means it is not a function. If I come over here to the second example, again, drop your vertical line anywhere you would like. Notice on this graph it only crosses it once. So it's saying for every x, there's exactly one y value. So this would be a function. So again, the vertical line test, if it crosses it more than once, no, it's not a function. If it only crosses it once, then it is a function. Now what we're going to spend the majority of the time on today is finding domain. So let's think about what is domain. Well, domain is going to be my possible x values. Which, remember, we talked about our x values as being our input. So today we're only going to focus on domain algebraically. So how would we find domain algebraically? Well, basically we're going to have three rules that you're going to follow. And every single problem is going to fall into one of these three rules. Alright, so the first rule is if you have a rational expression. Alright, first of all, what does it mean to be a rational expression? Remember, that simply means x is in the denominator. Alright, so what are we not allowed to have in the denominator? Well, we're not allowed to divide by 0, so we can't have 0 in the denominator. So all you're going to do is you're going to set denominator equal to 0 and solve. So therefore, your domain, and I'm going to denote domain with a capital D, domain will simply be all real numbers, but x cannot equal blank, whatever you just found. Now our second rule is going to be if I have a radical with an even index. Remember, the even index means the square root, or the fourth root, or the sixth root. You get my point, etc. Remember, the index is that small number with the radical. Well, what are we not allowed to have under a radical with an even index? Well, we can't have a negative number under a radical with an even index. So what we're going to do is we're going to set the radicand. Remember, the radicand is simply what's underneath the radical. You're going to set that greater than or equal to 0, and you're going to solve it. Well, when we solve it, your domain will simply be written in interval notation. Now, my last rule is going to be not a rational expression. So not number 1 or not number 2. So not a radical with an even index. Well, if it doesn't fall under one of my first two cases, it's very simple. It means your domain is going to be all real numbers. Remember, all real numbers in interval notation is negative infinity to positive infinity. So remember, I would accept either one for your answer. Alright, so like I said, every single problem is going to fall into one of these three cases. Alright, so let's look at my first example here. Alright, notice f of x equals x minus 3 over x squared minus 9. Well, notice I have an x in the denominator, so that is going to be considered a rational expression. So all I'm going to do is I'm going to take x squared minus 9, set it equal to 0. Well, I'm going to notice, okay, this is a difference of two squares, so I'm going to factor it. So I'm going to get x cannot equal two numbers. X cannot equal positive 3 or negative 3. So technically, your domain would be all real numbers, but x cannot equal plus or minus 3. Now realize that on your MyMathLab assignment, it may ask you to write your answer in interval notation. So let's look at this on the number line. So negative 3, positive 3. It says it cannot equal that, so it's going to have a hole there. But it includes everything else. So if it includes everything else, see how it's breaking it up into three intervals. So my first interval would be negative infinity to negative 3, parentheses because it cannot equal that, union negative 3 to positive 3, union 3 to infinity. So if it asks you to write your answer in interval notation, that's how you're going to have to write your answer. Or it also might have this set notation, and it'll have this typed out for you. So set notation is going to look something like this. It'll have bracket x bar, and then it'll say x cannot equal blank and blank. So in those blanks, you would simply type negative 3 and positive 3. So again, the MyMathLab kind of just goes back and forth between how it wants its answer written, so pay close attention to that when you're working on that. Alright, number 2, notice I have a radical and the understood index is a 2, so this is going to fall under case number 2 where we have a radical with an even index. So all I'm going to do is take my radicand, so that's simply what's underneath the radical, and it says set it greater than or equal to 0. It's always going to be greater than or equal to 0. So now I'm going to solve. So I'm going to subtract 8, divide by negative 3. Remember, I divide by a negative, so I have to flip the sign. The double negative will become a positive 8/3. So now my domain, if I write it in interval notation, is this going to positive or is it going to negative infinity? Well, it says it's less than, so it's going to go to negative infinity. So my answer would be negative infinity to 8/3. I have an equal to sign, so I'm going to have a bracket. So my domain would simply be that. Now these problems, it will always ask you to write it in interval notation, so there shouldn't be any confusion there. Alright, let's take a look at number 3. Well, first, do I have an x in the denominator? No, I don't have a denominator, so it can't be case number 1. Do you have a radical? No, so it can't fall under case number 2. So that means it has to be case number 3, which means you don't have to do anything at all. Your answer is just all real numbers. Remember, it may ask for interval notation, which would be negative infinity to positive infinity. I'm going to stop right here, and I'm going to pick back up with the remaining problems on another video.